For multi-DOF system, we have more than one mass. It's more complicated system. So maybe we will consider for two masses like M1 and M2. Okay, there is one spring force, one damping force, spring force K1, constant is K1, its constant is C1, coefficients, sorry, K1 is coefficient, C1 is coefficient. There is K2 and here it is C2, it is K3 and it is C3, force F1, and due to this force there is x1 displacement. Here it is F2t, and due to this displacement is x2t. Okay, now how many force you need to write? There are two forces, so we will write for F1 and F2. So for F1t and F2t. Okay, so when we have some external forces, there are forces which will oppose them. Here is one is due to the M1, that is the inertial force. One is due to this spring, one is due to this damper. Other which will be connected with the M2, that is this spring and this damper. Okay, so write one by one. So in the free body diagram, you can make M1, if 1T is this side, so all forces which will be, one is due to the inertial force, that is due to M1, due to a spring, due to C1, the other force due to K2, other force due to C2. Okay, so how we will write it? We will write M1 x1 double dot. For simplicity, we are removing t over here. All are dependent on t, but we are not writing t. So it is M1 x1 double dot plus K1 x1 plus C1 x1 dot, and here we consider that x1 is greater than x2 because it is connected with M2, that's also pulling with some force, that is F2. So there is a displacement in K2 due to both forces. It means due to x1 and F1 and F2 means it is due to x1 and x2. Their elongation here is due to x1 and x2 both. But for simplicity, we will consider it that x1 is greater than x2 here, and we will write K2 x1 minus x2 plus C2 x1 dot minus x2 dot. Okay, now we want to write in form of x double dot, x1 dot and x2 dot. So we will manipulate this equation. So we will write mx dot x1 dot. So if we will open the bracket, it would be C1 x1 dot plus C2 x1 dot minus C2 x2 dot plus K1 x1 plus K2 x1 minus K2 x2. Then M1 x1 double dot plus, we will take the common as a x1 dot, so it becomes C1 plus C2, then minus C2 x2 dot plus, here we will take common as a x1, so it is K1 plus K2 minus K2 x2. So you can check here that it is x1 dot, it is x1, all coefficients we have put apart. Okay, so this one is equation for F1t. Okay. Similarly, if you will write for F2T, will you please let me know what should I write here? Now we will consider this M2. So for the free body diagram for M2 will be, it is for the K2, for the C2, of course for M2, then for the K3, for the C3. These all are forces which will oppose F2. Okay. So tell me, what should I write here? First, the inertial force, that is M2 x2 double dot plus K3 x2 plus C3 x2 dot plus K2. Now for this mass we will write x2 first. x2 minus x1 plus C2 x2 dot minus x1 dot. Okay. Further manipulation because we want in the same format. So M2 x2 double dot plus C3 x2 dot plus C2 x2 dot minus C2 x1 dot plus K3 x2 plus K2 x2 minus K2 x1. M2 x2 double dot plus C3 plus C2 x2 dot minus C2 x1 dot plus K3 plus K2 x2 minus K2 x1. It is F2 T. You can write them in a matrix form. So for the matrix, form you have two equations. So you can write here x1 double dot x2 double dot. Here it is equations. You can write F1T over here. So you will write x1 dot and x2 dot. What will be the matrix? In this, there is, for the x1 dot, it is M1 only. There is no term for x2, so it would be 0. And in this, it is only M2. There is no term for M1, so it would be 0. Okay. Now for x1 dot and x2 dot. For x1 dot, it is C1 plus C2, and for the x2 it is minus C2. So you will write here minus C2. For the x2, the x1 term is minus C2 and this term is C3 plus C2. Now for the x1 and x2. So for the x1 and x2, and here we will write F1 and F2T. Okay, for the x1 and x2, for the x1 it is k1 plus k2 and minus k2. k1 plus k2 minus k2. Here it is, for the x1 it is minus k2 and it is k3 plus k2. Okay, this is inertial matrix, which is mostly symmetric and positive definite. Okay, this is damping. This is stiffness matrix. Okay, and this is vector for the forces. Got it?